Hello, we are Laurent Gabriel and Adrien Kislanski, and we are pleased to present you here our multimedia presentation. We will try to answer this question. To what extent was BMW hydrogen car a technical failure? And the others? But first, who is who?
Hello, this is Adrien Kislanski and this is my voice.
Hello, I'm Laurent Gabriel and this is my voice. Today, more and more, we are aware about the critical situation of the climate change. This evolution is directly related to the massive CO2 gas emission. As most of human activities produce this emission, it's of the higher importance to develop and improve new technologies which help to protect our nature. Many studies already evaluate the origin of CO2 pollution. The results are shown on the pie chart. It shows three bigger sectors producing about 80% of the carbon dioxide. As shown on this pie chart, road transportation, purple on the graph, which includes cars, motorcycles, trucks and other road vehicles, contributes for about 20% of the total CO2 gas emissions. In comparison, air and marine transportation together contribute to less than 10%. This proves that it's important to promote improvements to this road transportation sector. To give a pragmatic idea of the impact of this phenomenon, typical production of CO2 gas for family car is between 130 and 190 grams per kilometer. See table hereafter showing figures for different Vauxhall Meriva models. In comparison, average production of CO2 for a human being is about 900 grams for a 24-hour day. This corresponds to a 4-kilometer trip with a normal car. Let's now have a look at some examples of new technological developments in this domain.
I will present here only three cars, each one emblematic of their own technology. These cars are not prototypes, they are or have been produced. The first is a Toyota Prius, an hybrid car which uses an electrical engine for small speed and a fuel engine for full speed. The second car is a BMW Hydrogen 7 which uses an hybrid engine, gasoline or hydrogen for fuel. I will speak more later about this particular model. The third car is not an hybrid car or have any hybrid engine. The Tesla is a 100% electric car which has proved its efficiency amongst time. In 2006, BMW announced the production of approximately 100 models of the new Hydrogen 7. The Hydrogen 7 is a Series 7 BMW with a V12 combustion engine which can use for full gasoline as well as liquid hydrogen. In a facility, hydrogen and oxygen are separate as the following formula indicates. Then, H2 is conserved and stored into liquid state. Finally, H2 is mixed with O2 in the motor in a very particular environment of pressure and volume. The production of H2O is explosive and, as gasoline, the explosion is used to run the engine. At the end of the cycle, the combustion engine rejects only H2O, as known as water. The following link returns to a simulation of the Hydrogen 7 engine. The Hydrogen 7 has two tanks, one for the gasoline and the second for the liquid hydrogen. As you can see, the H2 tank takes half of the chunk. To stay liquid, H2 must be stored at 253 degrees Celsius below zero. The car consumption is average 14 liters per 100 km for gasoline and 50 liters per 100 km for liquid H2. Despite this difference of consumption in the engine, the user doesn't feel any difference between the two fuels. As you can see, we already have three problems which appear. First, the V12 engine is glutton. It uses a lot of amount of gasoline and a huge amount of hydrogen. So we ask ourselves this question. Is it better to consume a few diesel or a lot of gasoline? Second problem. The stations must be adapted to store liquid H2. There is a few of such stations in Germany, one in Berlin and several in Bavaria, home of BMW. However, if the use of hydrogen car become current, it doesn't remain a problem. The third problem is the losses of liquid hydrogen by heat. They are inevitable and, as it seems, very important. In 9 days, half of the H2 tank is lost, evaporated.
As shown just before by Adrian, a lot of effort is invested in the development of new technologies. We are still at the beginning of major evolutions, and all of these researchers have their advantages, but also their drawbacks. Let's have a look at a comparison table between some of the new sources of energy. Among all possible solutions, we choose 4 typical alternatives, which are the electric car, the hybrid car, the original air engine, and the hydrogen solution presented by Adrian. First, we can see that the electric motors rarely fail. Nevertheless, it uses an acid battery which is very heavy. Autonomy is limited while long time is required to reload the accumulators. The price also is significantly higher than traditional fuel cars. The hybrid solution is a combination of a fuel and an electric engine. It appears as a transition with the advantages of fuel cars, autonomy for instance. The electric engine allows a significant reduction for CO2 emission, mainly at low speed. Air engine appears to be an original finding. Compressed air is abundant, economic, and clean. Main drawbacks are the limited autonomy and the low energy volume rate. Finally, the hydrogen model presents the advantage already discussed by my colleague. Nevertheless, this technology requires a new energy distribution network, very dangerous due to explosive properties of this gas. We have presented here 4 technological axes leading to reduction of CO2 emission. Other research programs are of course in the pipe but remains up to now often at experimental level. Currently, the hybrid solution is the most marketed alternative. It's probably because it allows people making a step for the environment while comfort of use is guaranteed.
During this presentation, we spoke about the new types of technology that makes car more ecological. But we never get the big picture. For example, the electrical cars need battery, which are made with lithium. Unfortunately, the lithium is a very toxic element which pollutes water and ground. The color of the water in this picture is not paradisiac. It's due to the oxidation of lithium in the water and it kills every living organism. Second example. To produce liquid hydrogen, you must spend a lot of energy. In Germany, most of the energy is produced with coal, lignite, and gas. These 3 components are among the most important sources of pollution on Earth. The pollution reduction made with an ecological car is compensated by the additional pollution made for the production of the same car. We must be aware of this fact and aboard the ecologic engine with the means of production in mind, contrary as we do it now. Improvements are thus also expected in this domain. As we see, the world of the technological research and engineering is still open to more and more creative engineers. Let's hope we will be part of those who will contribute to build a better world.
Thank you for your attention.